Welcome to another Machine Monday. So the final part of our QA series is actually with the GOM. And I'm back with Roan because Roan Original didn't want to take part in this. But Roan, thank you for standing in.
That's a pleasure.
So we're at the GOM. I really am intrigued by the GOM. I think it's an amazing machine. Maybe just talk us through what is the GOM, what does it do?
Okay, the GOM is a 3D optical scanner. So when we get parts, we can actually scan our parts in as a 3D model, STL file.
Okay.
And we can compare it to actual CAD.
Okay.
So we use it to check all our parts from machine shop as well. So we have a record to show that the component was like this. So if there's a replacement part, we can actually manufacture it the same as it was before.
Yeah. So it actually takes a 3D scan.
Yes.
Of a component. Here's an example, and you can actually overlay the actual component over the CAD, and you can see where the differences are.
Yes.
What I also know is obviously these tools that would go into machines would often be manually fixed to get the shape right of the part, and so you can then scan even the manually corrected tool, so you know exactly what left, so that when, if I understand correct, when the customer orders a spare part, you can actually make it to what left.
Yeah, we can actually get the model and machine it according to the model.
The actual part, not the theoretical.
The STL file that we have of it.
Okay.
The dots is our reference points.
Okay.
So we need to turn the part to scan it. So the reference points actually tells you where the part is at the moment, so you can build it.
Okay.
So then we need to spray. This is just a floor finder developer powder. We just spray it on the part to reduce the reflection. Otherwise, you won't be able to scan it.
Okay. Okay.
So then we scan one side. Then we turn it around. Then the reference points on the part, you use it on both sides to actually create one STL file.
Okay.
Model.
All right. And then obviously that's a laser scanner inside there. So you obviously would rotate it around.
Yes. That's our CAD model.
So that's actually the CAD model.
That's a CAD model. And then we have a surface comparison from our STL to our CAD model. That looks like this.
Okay.
Red means plus material. You can see that's plus,
so plus.
And you've got the blue, that's minus. Plus 0.4.
0.4, okay.
And
then the blue is minus.
The blue is minus.
Okay.
And usually the green, it's within 0.1 plus, 0.1 minus. But we use our deviation points to actually show how much is left on it.
Okay.
So if we see this, especially on these last like 60 microns plus, we send back to machine shop, they check it again, do the ship again, then
so I see there's a red section by the round hole there. What is that telling us?
That's machining holes, but now the machine shop made it a bit smaller, but it just shows this plus material.
Okay. So that's not important really,
because for machining.
Only for machining. Okay. Roan, thanks a lot.
It's a pleasure.
As usual, I always learn a lot when I come talk to you guys. Thank you.